Westerona. I'm Lucas Shen, and I'm really excited to be hopefully getting into Lakeside. And I was really intrigued when you showed us the two curiosities on the open house on November 15th. And the first curiosity is in the last video, and this is going to be talking about the second curiosity. So, in case you're not Westerona and you're watching this video, I am talking about this cool math thing, and I hope you enjoyed it as much as I did. So, let's get started. Basically, the curiosity is to take any prime number greater than 3. So I'm just going to represent it as n. So n is greater than 3. And remember, n has to be a prime number. I'm just going to call p actually, because p is a better thing for prime, because p can sit for prime. So p is greater than 3. Then I have p squared, so that prime number squared, and it has to be greater than 3. So if I square the prime number, and then I subtract 1, it is going to be a multiple of 24, which means it's divisible. If I take 5, I square, I subtract 1, that's equal to 24. If I take 7, I square, I subtract 1, that's equal to 48. They're both multiples of 24. You can keep going on and trying this, and it's always going to be a multiple of 24. So, although this is small, you can't see it, but I said it all out and I hope you heard it. I'm going to erase this since I'm not going to really show this. But I will keep p is greater than 3, so I can prove it. Immediately I was kind of stuck. I looked at this, and then I asked my dad for a hint. He said to use algebra. I was already using algebra. So then I started thinking about, I got a little bit sidetracked, and I started thinking about what I was doing in math class, in this outside of school math class that I did. I was thinking of quadratics. Oh, whatever, I don't have to write it out. And quadratics, factoring quadratics are something like x plus question mark in parentheses times x plus something in parentheses. So then I have to multiply this out. Then I realized this was a quadratic. This was p minus 1 times p plus 1. And then I saw that this made it easier, because I'm just going to show you if I substitute this out with, let's say, 5 minus 1 times p plus 1. Oh, I forgot to write 5. Then that becomes 4 times 6. And that's different from 5 squared minus 1. So now I have 2 different methods that I can use to get the same result. And this is very clear. I use this a lot. First, I took 24 and I factorized it. 24 is equal to 2 squared times, 2 to the third power times 3, or 2 to the third power is 8 times 3. So that's one of the 2 multiples to multiply. So if I factor it out in prime numbers, it's 2 to the third power times 3. They're the 2 smallest primes. So I have to figure out how to show three twos in any 3 2s and 1 3 in any prime number minus 1 or any prime number plus 1. So first I started listing multiples of 3. So there's 3. Well, I'm just going to write like numbers out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, dot, dot, dot. Well, I can't write dot, 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 but it continues. So I looked at all the odd numbers because a prime number must be odd unless if it's greater than 3, because the first prime number is 2, and no prime number can be a multiple of any previous prime numbers. So a prime number above 3 cannot be a multiple of 2. So I'd circle 5, 3, 5, 9, 7. So I know the prime is odd. So I'm just generalizing odd so that I can make it easier. And then I notice that all the odd numbers are either A, multiple of 3, or B, adjacent to a multiple of 3, or consecutive with a multiple of 3. For example, 5 is consecutive with 6, and 7 is also consecutive with 6. But then with 3, it is a multiple of 3, and 9, it is a multiple of 3. I can discard the multiples of 3, however, because first of all, the prime number has to be greater than 3, so it cannot have 3 itself. And like I said just now, any prime numbers above a previous prime number cannot be a multiple of that prime number. Like with 2, same with 3. So I can't have any prime numbers that are multiples of 3. So I can immediately discard these. And I can say any prime number is going to be consecutive with a multiple of 3. So I already have a 3. And I can say if all prime numbers are odd, which is true, besides the first prime number, because the first prime number is 2. So if all prime numbers after 3 are odd, then I have a multiple of 2 on either side, because consecutive to any odd number are even numbers, and vice versa. So consecutive to an even number are odd numbers. So then I can say I have 2 squared already. Now I have to have another 2. So instead of looking for 1, 2, I looked for 2 2's. Since I already have looked for all the singular 2's, I'm going to look for 4, which is 2 times 2, or 2 2's. So then I look at all the odd numbers again, which are 3, 5, 7, 9. So I looked at 3, and I said, well, it's right next to a multiple of 4. 5 is also right next to a multiple of 4. 7 is also right next to a multiple of 4. But then 11 is also next to a multiple of 4, which is 12. So then I noticed, because there's a multiple of 4 every 4 numbers, any odd number you take is going to be consecutive with a multiple of 4. Since the one in the middle, which isn't going to be adjacent, is an even number, since the pattern is even, odd. So this one isn't going to be adjacent. But since it's even, it's okay. So I can say that any odd number is going to be next to a multiple of 4, except for 1, because 1 is next to 0 and 2 in either multiple of 4's. But that's because 0 is, 0. And because it's earlier on in the numbers. And also I can discard it, because 1 is not a prime number. Although it meets all the requirements of prime numbers, it isn't considered one. And also, it isn't above 3, so even if it was a prime number, I would also discard it. So once I have that, I have another 2. Instead of having 2 2's, I have 1 2, because I already have taken one of the 2's by saying both of the numbers consecutive are even. So then I have 3. So then I know any prime number, if you subtract 1 and add 1 to it, and then multiply those two numbers together, you're going to have at least 1 3 and at least 3 2s. Oh, yeah, 3 2s. So then this multiplies up to 24, and that shows that any prime number squared and subtract 1, or this too, because this is the same as that, is equal to a multiple of 24. Thank you for listening. Bye.